Yay!
Yay! Okay, before we start doing actual circuit diagrams, it's going to be really helpful if we're studying DC circuits to know how resistors in particular combine together in series and parallel. So if we don't have that down, it's going to be really hard to get very far on circuits. So here's just a little bit of practice. Suppose I have four 12-ohm resistors. So each of these are going to be 12 ohms, and I just have a little box of four of them. Here's all the possible ways I could think of that you could arrange them. Maybe there's more. I don't know. These are all that I could come up with quickly. Okay, well, what could you do with them? I could string them end to end. So for A up here, let's see. What would be cool is to use, let's use a different color just so they don't all blend together. So for A, what I'm interested in is what is the equivalent resistance of all four of these? So if I've only got four 12-ohm resistors in a box, what if I arrange them like this? What's the total resistance of something like this? Well, that's the easiest one, right? Because resistors laid end to end, if they're in series with each other, you just add them together. So this is just going to be 12 plus 12 plus 12 plus 12, or it's going to be really easy, 48 ohms. There we go. So I'll just go ahead and put a box around it. So that's going to be the resistance of that little network. It's useful because a lot of times in applications, if you're actually building something, you might want a very particular resistor, but they don't come in your exact resistance needs. You might just have a box of standard sizes. And so by combining them in clever ways, you might be able to build the equivalent resistor that you need. So if you don't have a 48 ohm resistor, but you got four 12s, well, there you go. Now you got a 48 ohm resistor. What about B? What else could I do? I could arrange them all in parallel with each other. I could do that. And so here, the equivalent resistance is going to be, how do you do it? You add up all the reciprocals, right? So this is going to be 1 over 12 plus 1 over 12 plus 1 over 12 plus 1 over 12. And then the thing that people forget, this is the most common mistake, is you forget to flip it at the end. You got to add all the reciprocals and then flip it. Well, that's going to be pretty easy. 12, 12, 12, 12. So if I had four of them, I got 4 12ths. That's a third. And then if I flip a third, I'm going to get 3 ohms. So there we go. Here's how to build a 3 ohm resistor out of 4 12s. It's interesting that when you add more resistors in parallel, the overall resistance goes down. That's kind of cool. What else could you do? How about C? I could arrange them like this. So I have 2 in series and 2 in parallel. So here, how would I figure out this equivalent resistance? I've got a 12. I collapse those 2 in parallel. I make that one equivalent resistor like this. So that's going to be a 12th plus a 12th, and then I flip it, and then I add the last one, a 12. All right, take care of the middle thing first. A 12th plus a 12th, that's 2 12ths, that's 1/6. And then when I flip it, I get 6. So this thing just becomes 6. So 12 plus 6 plus 12, that looks to me like it's going to be 30. All right, so there's another combination. If I arrange them like this, I can get a 30 ohm resistor. That's neat. D, how about this? I can do 1 in series with 3 in parallel with each other. So here, I'm going to do 12 plus, and then I'm going to do 1 over 12, 1 over 12, 1 over 12. Flip it. Let's see. So let's do the thing in the brackets. That's going to be 3 12ths. That's a fourth. And so when I flip a fourth, I get 4. So 12 plus 4, I get 16. All right. And then the only other combination I could think of is the one in E. Okay, so out of these 4 12-ohm resistors, I've been able to make 4 different resistances, right? 48, 3, 30, and 16. That's kind of cool. What about this thing in E? Let's try that. This thing is going to give me, let's see, this is going to be 1 over 12 plus 1 over 12, flip it, and then I just add the next one. It's in series with the next thing. 1 over 12 plus 1 over 12, flip it. Okay, so that's what? Each one is 2/12. That's 1/6. And when I flip it, I get 6. And when I add 6 plus 6, I get 12. I mean, maybe that's a little pointless. If I combine 4 12-ohm resistors, I get something with a resistance of 12 ohms. I don't know what to make of that. That's a little boring, maybe. But maybe at the same time as being boring, it's also a little bit interesting because, I don't know, you could have fun with it. Maybe this is like a self-similar fractal arrangement of resistors. Because if I can string 4 of them together where the total is 12, then you can think about it this way. What if like that one is just this whole arrangement, right? So this is like maybe this thing is an arrangement of the same thing there, right? And then each of these is a similar arrangement. So microscopically, it just keeps going down. Anyway, I can't think of a use. It's probably a complete waste of resistors. But anyway, it's sort of an interesting fractal notion of resistance. Probably that has no use. But anyway, and here's a little shortcut. Anytime you have 2 resistors in parallel with each other and they have the same resistance, like here, look what happens. You always get something that is half of the original resistance. It's good to have little shortcuts like this in your head so you can do these kind of things fast. So if you have 2 resistors that are the same in parallel with each other, in tandem, they have half of the original resistance. You get, I mean, you can kind of show this if you have, if each of them are resistance R, you get 1 over R plus 1 over R to the minus 1. So what is that? 2 over R? And then you flip it, and you just get R over 2. So anytime you have identical resistors in parallel, you just half it. And that'll make doing some problems just a little bit faster, because then you don't have to go through the calculation. Okay, so now that we've had a little bit of practice in doing series and parallel combinations, we will do a couple of actual circuits.